Okay, so looks like number 5 is kind of like a two-parter. The data below were collected for an enzyme-catalyzed reaction. And then they give values of the concentration of the substrate. And then they want you to calculate Vmax and Km for this reaction. And also to graph it. So first I'm just going to write down these concentration values. And then these velocity values. Okay, so now that I have those written down, I'm also interested in finding the inverse of these values as well, since this is what we are going to graph in order to find Vmax and Km. So I'm just taking the reciprocal of both of these values. And then if you were to do 1 over 0.2, you get 5. 1 over 0.5, you get like 3. 1 over 2 is 0.5, and then 1 over 4, 0.25. And let's look at the reciprocal of these ones. You get 1.16. And then let me just see. If I wrote this down right. Is 1 over 0.8. Yeah, so 1.2. And then let's do 1 over 2.22 is 0.45. And then 1 over 3.08 is 0.32. Okay, so now I want to graph these values. I'm going to do it on the right side here. So on the x-axis, I'm going to do the 1 over concentration of substrate. So from 0 up to 5. So then for the y-axis, it's going to be the 1 over the rate. So let's do it like 0.1. No, that's not gonna work. Let's do 0.2. So just like a rough graph, I'm gonna try to plot these. And this is not to scale, but basically what you should get in your graph is like this. You should see like a straight line if you were to do this like properly. And what we're most interested in is the equation of this line. So if you were to use like Excel or Sigma plot, you get an equation of this line, which is y equals 0.17x plus 0.3. So basically, 1 over V max is equal to your 0.33 value. So therefore, we can calculate for V max, and it'll be equal to 3.0. And then secondly, for our slope, we know that the slope is equal to Km over V max. And the slope of the line is 0.17. So then subbing in our V max value, you get 0.17 times 3.0. And then our Km value is 0.51 mm. So that's for part A of 5. Just since this is such a different question than part B, let's see what our junior tutor said. So they plotted the reciprocals. They got a different value here, but the rest are right. I think that just from that one mistake, it kind of messed up their math a little bit. I'm just gonna correct them and say the equation of the line should be y is equal to 0.17x plus 0.33. Therefore, V max will be equal to 3.0 over S, and Km will be equal to 0.51 mm. It doesn't look like they answered part B of this question, but I'm just gonna do it right here. 5b. An enzyme has been identified with the active site shown below, drawn as at a physiological pH. You have been asked to design a peptide that binds tightly in this enzyme pocket. Which of the given amino acids are likely to interact most strongly with each region at physiological pH? And then they just give us different options of amino acids. So first let's look at region 1. So this amino acid is cysteine. Cysteine. And then basically, out of all of the options that are given, I would say that out of all of them, then the threonine would interact the most strongly. So let me draw out the structure of threonine, and I'll explain why once I finish writing it down. So you'll see it contains an alcohol group there. And if I were to also draw our cysteine in this way as well, and again there's a slightly positive hydrogen, slightly negative sulfur. And you can see that hydrogen bonding can take place for these two amino acids. So therefore, since they can form hydrogen bonds, therefore it's threonine. Okay, so now let's look at region 2. So region 2 has like a 2-ring structure. If I don't butcher this. Kind of like that. This is the structure for tryptophan. So you'll notice that there's a benzene ring. There's also an amine group involved. So because of this kind of structure, out of all of the given amino acids, like which one would react the best, I would say tyrosine. So the structure of tyrosine is as follows. Basically, you have your OH group that's attached to a phenyl. Then you just have the remainder of this amino acid. This is tyrosine. So you'll notice that there can be a possible pi-pi interaction. But you'll also notice that phenylalanine also has a benzene ring, but since tyrosine has this extra alcohol group, you could potentially also form hydrogen bonds. So that's why tyrosine was selected. And lastly, let's look at region 3. So this one might be the easiest to figure out. And that's just because it has a negatively charged oxygen. So basically, which one of these amino acids has a positively charged nitrogen? So this is aspartic acid. And then out of the 3 options that they give us, lysine is the one that can have a positively charged nitrogen. So its R group looks like this. And I'm going to draw it with a positive charge just so that we can picture it. And then there's its carboxylic acid group. Here's the NH. This would be positive as well. And then this is lysine. Basically, positive reacts with negative. So I'm also gonna write this down. For the second part of the question, region 1, Threonine due to H bonding. Region 2, Tyrosine due to H bonding and pi-pi interactions. Then region 3 would be lysine due to positively charged. And reacting with the negatively charged O. Yeah, so the junior tutor wrote down the correct work. So let me just say that the work was correct. But 1 over 0.37 should be equal to 1.16. Okay. And then I also just added the second part of